which is what we have here. Right, so let's see how we go about that. Well, first, let's save 1 factor tan x sec x, right, because we need that in our final expression. So we'll take out a tan x and a sec x. Right, what we'll be left with is a tan to the 4th and a sec to the 8th dx. Right. So this term we want, here we have a sec to the 8th, right? That's also one of the kinds of terms we want. Right? We want the power of sec. So the only thing that's bothering us at the moment is this tan to the 4th. Now remember, we can write tan to the 4th as tan squared squared. And now we can use the identity tan squared plus 1 is sec squared to convert tan to the 4th to a bunch of powers of sec. Right? So we're going to replace tan squared with sec squared minus 1. Right, so this is then sec squared x minus 1 squared. And we multiply out. We get sec to the 4th x minus 2 sec squared x plus 1. Now we just substitute this expression for tan to the 4th into our integral. So what we get is I is equal to the integral, right? So we have tan x sec x, and then we have tan to the 4th, which we can write sec to the 4th x minus 2 sec squared x plus 1, and times all of that sec to the 8th x. And now we can multiply sec to the 8th into our expression. Right, so we have tan x sec x times, right, so then we'll have sec to the power of 12 minus 2 sec to the power of 10 plus sec to the power of 8 dx. Right, so now we have the powers of sec times tan x sec x, right, which is the derivative of sec. So we can integrate this. That would be 1 over 13 sec to the 13x minus 2 over 11 sec to the 11x plus 1 over 9 sec to the 9x plus c. Now, this technique will not work for all integrals involving powers of tan and sec. But it will work for some of them. Right? Now, what was the essential feature here? Well, we were able to take out a factor of sec and tan, right? And then we had left an even power of tan, right? So that we could use that identity for tan squared. So whenever you have integral tan to the 2k plus 1x sec to the mx dx, this will work, right? You can take 1 factor tan and 1 factor sec, right? So you'll end up with tan x sec x, right? And then you'll have tan to the 2k, or then tan squared to the k sec to the n minus 1. Right? And then this tan squared, right? We can now get rid of that with the identity. Let's say that it's equal to sec squared minus 1. Okay, so this